Now I see why you guys went offline. This is beautiful.
Today, I am at the Scalar School of Technology's offline campus. I'm about to get a crash course in how to build a drone by using off-the-shelf components from a team of brilliant 20-year-old students. These students will walk us through every step of the process, from selecting motors and propellers to integrating LiDAR sensors and AI for autonomous flight capabilities. Not just this, at the end of this, we will test it by actually taking a flight. So, without wasting any time, let's get right into it.
Yeah, man, would love to show you the campus.
Sure.
This is the campus, like you know the concept of SST, right?
Yeah.
By industry, for industry. So when we were thinking of the campus, we thought of how, from a curriculum design point of view, what Microsoft wants, what Amazon wants. Let me start with showing you the classroom.
Oh, this is huge. This is much larger than I thought it would be.
Now, this entire space that you see, we have equal amount of space on that side, which is the innovation lab.
That looks really exciting.
Let's
this
check
part
that.
is a classroom.
Yeah.
But that looks interesting. Hi. How are you doing? Good to see you. Likewise. This looks damn good. This actually looks good. This feels futuristic too.
This is your Robotics, Drone Lab, AR, VR, AI/ML, and that's your IoT lab.
This is drones. Hi guys.
Good afternoon, sir.
I'm going to be seeing a drone today. You're going to be teaching me how to
Hi, sir. This is Dave.
make and ride a drone. I know some of it, but hopefully you'll give me a full lesson on this. Hi. How long have you been working on this?
For the last 2 months.
Nice. I'm excited to see how it works.
Very excited to
So today we're going to find out like whether the drone actually flies and what it's made out of. So we're going to do 3 things. One is you're going to show me that the drone flies. Then there are 2 ways I learn, right? One is either I build something or I break it down. Breaking it down is much faster. So I would love to have that broken down because otherwise building it I think will take a few hours.
Yeah.
So you'll break it down layer by layer until we get to the motors and the ESCs and whatnot. You're going to explain it to me and then hopefully I'm able to understand it. Okay? I'm a drone noob though. I know nothing about drones except for the very basics. So you have to treat me like a layman. Okay? Shall we go?
Yeah.
Come. Can I fly it?
Yeah, do you have any experience?
So I have 0 experience flying a drone, but let me try.
Yeah.
I'm good with an Xbox controller.
So this is the throttle. So this will dictate the amount of thrust it throws down. And it will go up.
This is left and right.
This is called roll. Technically it's called roll.
Roll
So
pitch yaw.
Roll pitch yaw, correct.
Okay.
You know a lot, man, you're not a noob. So this is basically yaw. This is yaw. This is for the pitch and this is for the roll.
Okay, got it.
Yeah.
That's it?
Yeah, that's it.
Okay.
Yeah.
Let's start.
This is when we connect the battery and then there is an arm switch on board which will arm the quadcopter. So there are two arm switches. One is on the copter and one is on the remote.
You guys should move away
Yeah, they should move away.
because someone will die and then I'm not responsible.
Very slightly give throttle. Yeah, see it goes up. Then you can control it through pitch and yaw. Take it right. Yeah. Perfect. Take it right. Oh.
Shit. ये बाहर नहीं गया.
नहीं, luckily हम उस बार.
But this will be an autonomous drone.
Yeah, this will be an autonomous.
And it's driving how? Through LiDAR?
Raspberry Pi, and there will be a flight control system on board. Which will control it and give the hog the input which we give it through the radio. It will basically tell the drone to go.
No, but if it's autonomous, why are you giving it instructions?
We are not giving it the instructions. The Raspberry Pi on board will give it the instructions.
So play it for me. So it sees the world through LiDAR. It sees a 3D representation of the world. Can you explain what LiDAR is to the people watching?
LiDAR is basically an instrument through which we can sense the range of the object in front of the drone.
What's the full form for the audience?
Light detection and ranging.
Okay, nice. So it's seeing the world, it's giving you a 3D representation of the world.
Yeah.
Then you're bringing that world into the Raspberry Pi,
Yeah.
right? And then you're deciding where to navigate purely on the LiDAR and the camera.
Exactly.
Okay, but can the camera see behind itself?
No, for that the drone will just rotate 180 degrees.
Okay. You want to break that down for me?
Yeah, sure.
Okay. Hey, you want to quickly take a detour and go see the Vision Pro folks? Hello. You have to be honest. How many times have you used the device in the last 1 month?
Probably daily for 3 to 4 hours.
Really?
Yes.
Apple loves you.
So basically, when we renovate our home, so we are not able to visualize which panel will look good or how, with my furniture, how this color will go correct or not. So for that, we have built a visualization where you can place panels on your walls with your furniture applied. Means like if there is a TV and table, so panel will be placed behind that. So you can take a feel of your home with a new panel, with the extra thing you are adding, and you can decide which panel is looking good. Or wall panel, like nowadays, people are applying wall panels like wooden panels or some acrylic or something like that. So Urban Company has started a new segment in their business where they're applying wall panels.
So you're doing some kind of wall detection?
Yeah,
Yes.
wall detection and whole construction of mesh around the surfaces.
Nice.
So if you touch the any panel, it will be placed.
So if I touch this panel?
Yeah, you have to tap it from the index finger. Yeah, so it's placed.
Oh, nice. This is actually cool.
This is way better in the reception area out there.
No, this is still really nice. This is still really nice.
So that part is really great because the more complex it gets.
Yeah, segment all of this out. You can use SAM. You know what Runway ML does? Something very similar. You can do it in real time. So can I also tap that?
No, we have not.
Only walls.
Only disabled. The ceilings are disabled.
Nice. I'm already here to destroy the lab. And how are you doing this?
This we have used a combination of plane detection and mesh reconstruction.
Nice.
So to achieve the.
And how are you texturing the mesh? Why don't you use stable diffusion and texture the mesh so that I can just say, make it look like flowers and then there's a flower wallpaper.
So we are trying to work on that because there's a mesh resource. We can place the mesh. So currently we are trying to implement a video on it. So it will look like the matrix.
Oh, nice.
So on the whole layer, it will place matrix. So zeros and ones.
Like an LED wall.
Yes, like an LED wall. So instead of the wall, it will be the whole environment. So you will be inside the matrix.
Nice.
So we're trying to build that right now.
Nice. This is pretty impressive. Okay, back to the drone folks. Let's go see what they're up to. Start with this. These are the motors.
Yeah, correct.
These are all the motors.
Correct.
So then you got these. So how much does this cost? Just the fan.
Just the
fans.
fan, 50 rupees.
That's it.
Yeah, that's
How much
it.
does these motors cost?
600 rupees.
Nice.
Yeah.
And they're driven, I assume, by an ESC.
ESC, yes, you're right.
So the ESCs are here. Can you explain to the audience what an ESC is? And what it
ESC
does?
stands for an electronic speed controller. What it does is basically it takes signal from the flight controller. It gives the motor the current according to which the motor should spin, at what RPM should it spin. That is decided by the PixHawk.
What is the PixHawk? The flight controller.
Yeah, the PixHawk is the flight controller which we're using.
So the PixHawk is sending data to the ESCs, which is then controlling your motors, which is then making your fans rotate at a certain speed.
The job of the ESC is to control the RPM of the motor, in simple words.
Nice. And what does this do? What is radio telemetry?
Radio telemetry, through this we can make the PixHawk communicate to our laptops using a telemetry communication device.
So what, you can tell the laptop what the PixHawk should do?
Yeah.
I mean, the
No,
laptop can
the
tell
laptop
this
can
thing,
tell the PixHawk
what the
what to
PixHawk
do.
can do. What is this?
This is the receiver for the remote, for the radio controller receiver, radio receiver.
Can you show me the LiDAR and the camera module?
Yeah.
Yeah, sure.
This is the LiDAR. This is the LiDAR module. So basically, how it works is, you see there are two black patches on the top. Yeah. So basically, one sends light.
So it's only forward LiDAR? Usually a LiDAR module is 360.
No, this one is, that's what we said. This is a 1-point LiDAR.
Oh, okay. So
Single
it's only
point
looking in
LiDAR.
front.
Yeah, it's only looking in
It's
front.
creating a map of the world in front of it.
Yeah.
Nice.
And the drone can rotate 360 degrees, so we can create a 360 map as well.
Nice.
So how it works is, it sends this light beam, and this one receives the light beam. They are pointed like this. So it calculates the time which it took to send and receive, and it multiplies that by the speed of light to calculate the distance.
Got it. And what does that create? A 3D map of the?
Mapping is done on the software side. It will just tell the range of the object in front of it, distance of the object.
What is this?
This
It's
is the Raspberry Pi.
brain of the drone, like the
Nice.
where the ML models and all the object detection model, fire model.
You're running everything locally, nothing on cloud?
No, nothing on cloud.
Like there would be problem if it would run on cloud. Like it would need internet to access the cloud, right? So if we do that, the drone might fail at any point. We don't know. So
Basically, you're saying with this combination of the frame, your Pixhawk, your telemetry devices, your ESCs here, your motors, and your fans, anyone can build a drone at home?
yes.
Yeah, but with a little bit of knowledge about the calibration procedures.
Nice. Which
That's it.
Google.
Which is very easy to find.
Do you want to run me through the ML model that you guys have on the system?
Like the fire detection model, it would take the visual inputs from the camera and the LiDAR. Like from the LiDAR, it will calculate distance, but it will take the visual inputs from the camera and it will send to the RPI. And RPI, that it will take the one frame out of that video and it will process the image. It will detect the fire, and if there is a fire, it will do the PID control, that is like minimizing the error for it.
Yeah.
Whereas the
Because the camera is sitting on top of the drone and there's jitter. Is that why?
There is that to combat that thing. We have something called as a gimbal, which will stabilize the camera feed. And what it will do is, like right now the fire is over to this part of the frame. So what it will try to do is to bring it over to the center. So for that, there is this much error. So you see, like this much error is there. So to correct that, there is something called as PID controller. So the PID controller will determine how exactly will it move on to will it take this fire to the center. And once it's in the center, you just have to take the drone towards the fire. And then that's how we'll be on top of the fire.
So you're right on top of the fire then?
Then there is then there will be a custom-made dropping mechanism which we're developing right now, and it'll drop the ball onto the fire, and that's it.
Got it.
So basically, like the drone has to go forward. So what we give the input of forward. Let's say we give
So it translates that into exact rotation, so you don't have to map out what has to rotate at what point.
Exactly. Like if we tell it to go
Instead of you
forward,
manually dialing in RPMs, you're just saying forward, and that's translating into how should everything.
Pixhawk will basically sync all the motors with itself, the anti-clockwise with the anti-clockwise, with the clockwise with the clockwise.
So basically,
Fair.
like go forward. So how
It will
work
figure it
is-
out.
Yeah, it'll tell these two motors
Yes,
just
all
spin
it's all
faster
existing.
and go forward.
Got it. Yeah, I think everyone has a good view of how it works. So hopefully, audiences at home, you learned like me how a drone works and how it's able to put out fires with a combination of AI and 85,000 rupees roughly for the drone.
Yes,
Nice. Very, very, very impressive. Lovely. This is super impressive. Thank you so much for having the patience to answer all my stupid questions.
No,
And-
every question is important.
And very, very impressive. Are you guys planning to start a company out of this? Are you planning to commercialize this?
soon.
Nice.
we have plans, but we are
Not
working on it.
commercialize this, like do more of like non-profit kind of a thing.
Still very, very impressive. Congratulations. How old are you?
I'm 20.
You're 20 years old.
I'm 18.
I mean, oh my God. Shit. Superb stuff. My audience is used to the fact that we'll cover something and then they'll double click on certain things as they like. Some people will be like, no, I will build my own flight controller. Some people will be like, nahi, mujhe frame 3D print karna hai. Some people will be like, no, I want to use some other type of motors, whatever. Like you can feel, this is the baseline and you can feel free to modify it as you want. But what I'm also really impressed with is this nice Iron Man looking laboratory that you guys are sitting in.
All thanks.
And
What would you like them to build?
next? Yeah, what I would really like, what we are working on, I'll tell you. So again, we've just started a few weeks ago, but we are working on a quadruped bot. Right, so we got this bot from China called the Yahaboom Dogzilla. And there are many of these available. There's the Unitary Go 1 and stuff, right? So the cool thing about the bot is it's built. So there's a open source platform called ROS, Robot Operating System, where I can control the bot now through teleoperation, yes, but I can also write my own software for it to be my friend, for it to hang out with me, and it has all the devices built in. So I didn't need to buy like a separate LiDAR module. I didn't need to buy a separate camera module. Everything came in, right? There's this unique opportunity that Boston Dynamics did to put a skin on top of the bot.
Yeah. For the
I don't know if you saw this. They put a dog skin on top of it.
Yeah, spot.
So the question I often wonder is there a boat-like business possible, but for robotics and drones? And for anything, right? Like where China produces, or whatever. In the early days, China will produce it. We will build a business on top of it, reskin it, whatever. And then over time, you can bring the manufacturing back to India. Because the other way around is super risky, right? Where you build this, and then you commercialize this, and then what if you take it to market and nobody buys it? It's scary, and you've lost a lot of money, you've lost your money, investors' money, whatever it is. The other way around, where you're just buying a product and reselling it to see, is there a market first? And then once you've seen if there's a market first, and if there is a market, then you bring everything in-house, right? So yeah, like people keep saying India needs a lot more manufacturing, but actually India also needs an appetite for this, because I don't know who would buy consumer robotics right now in the country, right? So we are also experimenting. It'll take like 3, 4, 5 years for us to, and might not even work. Like 99% it might not even work. But as an engineer, that intellectual curiosity never leaves you. See, देखेंगे क्या होगा.
I mean, like people, if they get introduced to robotics, then they'll have that curiosity of learning.
Yeah.
So that introduction part is most important, I guess.
Yeah, I mean, one thing that people don't get, which, you know, I'm glad that this one lab kind of proves it, right? That software is not just one thing. It's not just React development, right? It's like, if you're good at software, you can do XR, then you could say, okay, I understand XR, like he's working on Unity right there, right? So it's not that different. Unity is, I mean, it is different, but it's not that different from what you're doing. Like pitch your role. I first learned it in Flight Simulator, Microsoft Flight Simulator. Then I've used it in Unreal Engine. And then I found the same concepts here, because you're moving in 3D space, right? So it's obviously eventually come through pitch, roll, yaw. So all the concepts translate, but the way regular engineering colleges is like very, it's very, you know, it's, you have to learn only this thing, or you have to learn only that thing. My question is, if you're a good game developer, right, why, then you can also translate some of those skills to robotics. If you're a good because a LiDAR, like especially the 3D LiDAR, not this one, but the 3D LiDAR is creating a map of the world, and you're navigating based on the map. In Unreal Engine, there used to be this thing. It used to be called AI, but it's not really AI. It used to be called something called Blackboard, where you would make decisions. You'd say, hey, here's a decision tree, right? All animations Unreal are state machines. So these concepts translate across platforms, across things you can do. And one of the cool things I really love about this lab is there's no differentiation. Like, it's not like this is the center for React Engineers India, right? It's like, okay, if you feel like going there and doing some XR, if you feel like you're also using AI in this.
Yeah, we are.
Right? So there's no real distinction. So what we feel when we do stuff is, it's experimentation, and maybe we might not build a successful robot or build a successful robotics company. Most likely that's going to be the case. But we learn something from it that we can apply somewhere else. And it's also good content, right?
Like it's all curiosity and the hunger to learn things and tinker things.
And it's fun. Like, what will you do in life otherwise?
Yes,
like,
Exactly.
I mean, I hate saying this because I'll get belted for this, but you should keep it anyway. But I think engineers good engineers generally have the most fun in life. Because I think scientists have even more fun. I wouldn't know. But just that feeling where something just works and you've sat all night. I'm sure you all know the feeling. I mean, you also know. You've sat all night and like, chal raha hai. So I have one last question around this. How did you guys get in? Did you just do? Does any 18-year-old just walk into this lab? Like, why are there so few of you? How did you get here?
Basically, like first of all, there's an exam called as NSET, and we have to clear.
What's it called?
NSET.
Spell that for me.
NSET.
Okay.
Yeah. You have to first clear that exam, and then there will be 2 sets of interviews. One will be maths interview, and one will be personal interview, in which they'll see your dreams and aspirations. And after these 2 interviews and this test, you're done. You're inside this institution.
The exam itself is kind of a learning thing. Like, there is a part called learnability, where they put the concept itself in real time and they ask you the question, what will be the answer of it. So
adaptive learning ability, not mugging.
Yeah. So they'll give you a paragraph which will teach you the concept. So in my case, it was like binary conversion. So I didn't know about that concept, but like I learned it on the spot, and I was able to like clear the questions on the spot. So you have to learn it on the spot and clear the questions.
Nice. Super impressive.
And it's not only like learnability, like if you have the logical reasoning and mathematics thing, you'll also get selected into this like college.
Yeah.
Like the maths thing in computer science also, in AI, ML, whatever thing you do, majorly in computer science, it's only maths what determines.
Yeah, that's the only risk with this place, right? The minute your entrance test becomes too easy, you get like someone bad who's not contributive in a group. You know, you have that, right? In a group project, even if one guy doesn't contribute, it's done.
Yeah.
So with offline institutes, like the entrance test is very important. I'm glad there's an interesting entrance. There's a good entrance test. How do people apply for the NSET?
NSET is like completely online. You just
What's
have to
the
fill a
link?
form. You'll have to fill a form. You'll have to go on to Scalar School of Technology's website.
You'll have to register it there and you can give the exam.
So that's been a look at the fascinating drone lab and the impressive offline campus at Scalar School of Technology. We got to see some brilliant students helping me understand how autonomous drones work by breaking things down. What really stood out was how they blend different tech skills. It's not just about coding or building things, it's about combining everything to solve real-world problems. If you're into tech and want to learn by doing, Scalar School of Technology might be worth exploring. So click the link in the description. That's it for this video, and I'll catch you guys in the next one. Bye!